Thank you so much for joining this lesson. We shall be discussing Mathematics Paper 2, Section 1. You can see people are already joining the broadcast, and we are going to start right away. You subscribe and share with friends so that they may join this live broadcast. So this is the paper that we're going to revise, and actually before the Kcse is done, I'm going to ensure that we revise almost all the past Kcse examinations. So stay tuned, subscribe to this platform so that you may get more of what we are doing. A very interesting number one question here in the section 1. Remember, in section 1, the 50 marks are always compulsory. So this is what I want you to know. The questions are compulsory and you should attend to all of them. So as I wait for people to continue joining, we shall get started. I know people will be joining us as we continue, but we cannot fail to start. So let's go to number 1. Remember to comment, remember to like, remember to subscribe. Just leave a comment telling us where you're coming from. Let us know where you are catching us live from. Mention your school. Let's know your class also. And we shall continue improving together. The roots of a quadratic equation are x equals to -3/5 and x equals to +1. Form the quadratic equation in the form ax squared plus bx plus c equals to 0, where a, b, and c are integers. Where a, b, and c are integers. It's good to obey all the instructions, like leaving all the constants as integers. So let's see how to progress in this one. We've been told that the values of x are -3/5, and also x equals to +1. Now, assuming that we solve this one using what we call the factorization method, then it means the step just before this final means that we add x +3/5 equals to 0 and x -1 equals to 0. That's why now we are having a conclusion that says x equals to -3/5 and x equals to +1. It means just before the final conclusion, we add their signs reversed, as you've seen me, then equated to 0. Now, before we had these factors equated to 0 separately, the step just before this one should have been x +3/5 in brackets, then x -1 in brackets, everything equals to 0. So this is now just after factorization. And for us to get back to the equation, now we are supposed to expand. How do we expand a quadratic expression on the left-hand side? We're supposed to take the first term, which is x, and we multiply with everything in the second bracket. That way, then the next term is a 3/5. It also multiplies everything in the second bracket equals to 0. Then now we can expand by opening the brackets. X squared, then minus x after multiplying by 1, plus 3/5 x minus 3/5. This is equal to 0. So now we can arrange the equation, group terms where possible, as we look forward to the final answer. Thank you. Thank you. Remember to invite your friends. I can see people from Nile Road Girls. Thank you so much for being around. Now I'm going to group terms. -1, +3/5. That is -2/5x. Therefore, now we are having x squared minus 2/5 x. Then we have minus 3/5. This is all equal to 0. So now we have already gotten the equation. But is it in the format that the examiner demanded? Not really. So we have to make it the format that the examiner wants it to be. We are supposed to do away with the fractions, by multiplying by the LCM of the denominators. The denominators here are both of them 5. So we shall multiply every term by 5. X squared multiplied by 5 becomes x squared, 5x squared, then minus 2x minus 3 equals to 0. So now this is the final answer now. We are now having the final answer. Thank you for watching us from Southern Sudan. We appreciate. We check number 2 now, which is a question on errors and approximations. It's good for you to know that our number is already attached on the wall. Actually, on every page, we are having that number. In case you need more consultations, you are free to reach out. I also bring to your attention that we are having a very serious program on Google Meet. We all know Google Meet, and this is where we are going to have our serious program. So you are encouraged to enroll. Kindly reach out through our number. It's already attached, 0704 15 3366. Just reach out and I'll give more information about those who are enrolling, and we shall grow together. So now allow me go to number 2, which is a question on errors. A tailor intended to subdivide a piece of cloth into 7 equal parts. She approximated 1 out of 7 meters to 0.14 meters. Calculate the percentage error in the approximation. So how do we calculate percentage error when approximations are involved? We begin by getting the error first. And what is error? An error, when we talk about approximations or estimations, an error is usually the difference between the actual value and the estimated value. The difference between the actual value and the estimated value. And actually, we talk about absolute difference. 1 out of 7, we subtract 0.14 that way. So we're going to take the error itself by taking the actual value minus the estimated value. That way. That one will give us the error. Then there is something else that we call percentage error. Percentage error is usually given by the error divided by actual value. Then we multiply by 100. Actually, I can apply it at this point such that for me to increase my accuracy now, I divide by the actual value at that point. Then everything now should be multiplied by 100. So through this now, I'll go direct to the answer. Thank you from Mary Hill. Anthony from Njiri, good work. Thank you. Yeah, I'm going to present physics. Actually, tomorrow it shall be physics. So after the subtraction, now we divide by 1 over 7. Then we multiply by 100. I'm getting exactly 2%. Let people know how to consistently apply their calculator, more so in questions like these ones. Consistently apply your calculator. Take 1 over 7 minus 0.14. That answer is already in the calculator. Then write answer divide by 1 over 7. Then after that, multiply directly by 100. Instead of transferring errors again, it's not necessary. So please consistently apply your calculator and get very accurate answers. At number 3, Amila was contracted to make porridge flour to support a feeding program. He mixed millet, sorghum, maize, and omena in the ratio 1:2:5:1. The cost per kilogram of millet was 90, sorghum 120, maize 30, and omena 150 Kenya shillings. Calculate in part A the cost of 1 kilogram of the mixture. So there is a mixture here whereby it shall contain 1 kilogram of millet. And remember, the 1 kilogram of millet is costing 90. So the cost of millet in this mixture shall be the 1 kilogram times 90 per kilogram plus, according to the ratios, 2 2 proportions, which means 2 kilograms of sorghum. And these kilograms of sorghum are costing 120 per kg. Plus, the other proportion is a 5. This is for maize, 30 per kilogram. Then we add finally 1 times 150 for a kilogram of omena. So this is now going to be the total cost of the mixture. But now for us to get the mixture per kilogram, then we are supposed to divide this by the total kilograms mixed. How many kilograms of mixed? 1, 2, 5, 1. This is 1 plus 2, which is 3, plus 5, 8, plus 1, 9. So we are having 9 kilograms making up the mixture. So now we can work out. Let me compile this. 90 plus 240 plus a 150 plus 150 once again. I'm getting 630. Then now I divide by 90, by 9, sorry. So a kilogram of the mixture is costing exactly 70 Kenya shillings. Yeah, 70 Kenya shillings. So I hope we are together up to that point. I've just interpreted the ratios. It is my hope that you guys are following keenly. It's also my hope that you guys are able to share the link with your friends. Tabaka girls, thank you so much. Job from Kangaroo School, thank you. Thank you, thank you, thank you. Ngumo boys, thank you so much. All right, now that you guys understand, let's check part B of the same question. The selling price of 1 kilogram of the mixture if the miller made a profit of 30%. For this miller to make 30% profit and the cost of a kilogram is 70, how much are they going to sell 1 kilogram? So 100% is 70 Kenya shillings. Now with a profit of 30, it should be a total of 130. This should be 130 times 70 out of 100. So this is now going to give us, let me compute this. This is exactly 91 Kenya shillings. So 1 kilogram of the mixture will sell at 91, so that there will be a profit of 30%. Yeah. For the miller to realize a profit of 30%, we need such a selling price. We are moving already in number 4. Remember, our number is on the board. Please consult, reach out for more programs. Yeah, make sure you improve. Please don't fail when shifting grades is around. Look at this interesting question on logarithms. Very interesting. Without using mathematical tables or a calculator, evaluate 5 out of 6, the logarithm of 64 to base 10 plus the logarithm of 50 to base 10 minus the logarithm of 2 to base 10, or 4 log 2 to base 10. All right, let me use the space even above the question so that I may have some decent work well organized. Without using tables or a calculator, we evaluate. So this is what we shall be doing. We shall be applying the laws of logarithms together with some application of indices. For instance, we know that 64 can be expressed as 2 to the power of 6. That is something we know. So we shall apply that is on indices. Something else that we should be aware about is that among the laws of logarithms, we know that n multiplied by the log of a is the same as the log of a raised to power n. And with this knowledge, now we are going to apply. Let's start by applying this law. There are many laws that we shall apply before coming up to with the final answer, but let's begin with this one. So in the first term, whereby we are having this, then we shall talk about the log to base 10. Instead of 64, 2 power 6. Let me write it well. 2 power 6 2 power 6. But we're supposed to know that 2 power 6 is now being raised to 5 over 6 plus the log 2 base 10 of 50 minus the log 2 base 10 of 2 power 4. Because this is a 4 which multiplies here, then it becomes a power. Are we together in that application of the first law that we've stated here? Let me now play along with the powers first before we get back to laws of logarithms. So we're supposed to know that according to indices, according to indices, let me use the space just next to this. According to the laws of indices, we have what we call the product law of indices, such that if we are having a power n, then this multiplies with m, then we resolve that a should be having the product of the two powers. And with that law of indices, then the first term becomes the log 2 base 10 of 2 power 5, because now 6 and 5 over 6 have to multiply. When 6 and 5 over 6 multiplies, we remain with 5 plus the log 2 base 10 of 50 minus the log 2 base 10 of 16. Yeah, that is a 2 to the power of 4, 16. Very true. Now at that point, we can get back to the basic laws, like the logarithm of a number minus the logarithm of another number, as long as the base is the same. This one is solved as log of a over b. And we also know the first law says that the log of a plus the log of b, this is the same as the log a multiplied by b. So we shall apply these two laws concurrently in this expression at this level now, whereby we know that 2 power 5 is 32. So we talk about the log 2 base 10 of, now because of the addition, 32 should multiply 50, and 16, because of the minus, should divide. Yeah, we should be together up to that point. So now let's talk about the log 2 base 10 of what? 32 multiplied by 50 over 16. This gives us exactly 100. That way. So this is not the final answer, but now we have fully applied the laws of indices. So we can let the log 2 base 10 of 100 be, let's say, t. So now we can solve for the value of t, whereby we can change the expression from logarithm now to index notation. From logarithm to index notation, we're supposed to say that, you know, the log of b to base a equals to c implies that. I want to explain how people convert logarithm expressions to index notation. So if generally we are having the log of b to base a equals to c, it means a power c equals to b. So that's how we relate logarithms and indices. Yeah, that's how we relate logarithms and indices. Thank you, St. Joseph's Kibwezi, Winnie, I notice you. Thank you. Nyeri High School, thank you so much, Collins. Yeah, we are coming up with the final step now. Look at this. To change logarithm expression to index notation, you've seen the relationship. If log of b to base a equals to c, then it means a power c equals to b. And at that point now we will say 10 power t equals to 100. So 10 power t equals to 100 is 10 power 2. Look at this level now. The bases are the same, and definitely it means the powers are equal. So the value of t is equal to 2, and therefore the logarithm of 100 to base 10 is equivalent to 2. So the final answer is 2. The final answer is 2. Test from Machakos girls. Thank you so much. Test. Kisumu Boys High School. Thank you. Let's continue inviting our friends now. I can see you guys are all from big schools. Yeah, thank you. Thank you. And I hope you can get our sound from wherever you are. Somebody's complaining. You can confirm whether the sound is clear from your side, please. Let me know whether you are getting me clear. Let me know whether you are catching us very well. Yeah, this is great. Githumu Boys, thank you. Okay, number 5. Let's look at this. A very interesting question again from circles, chords, and tangents. In the figure below, PQRS is a cyclic quadrilateral. Then PQ is equivalent to QR. The angle PQR equals to 105 degrees and PS is parallel to QR. Just as you can see indicated, that this one is parallel to this one. And again, we've been told PQ is equal to QR. They are equal in length. Then after that, what are we told to do? Determine the size of the angle PSR and also PQR. So we're going to fill some of these angles. Then now we check the angles that the examiner exactly needs us to fill. Now, from just what you can see here, I want us to fill a few angles. The first thing that you're supposed to know is that PQR is a triangle, as you can see from the diagram. So when we take 180 and we subtract 105, I'm getting 75. So it means the base angles, because PQ is equal to QR, this angle together with the angle at R are equal in size, and I'm going to divide 75 by 2. So 37.5. And also 37, that's 7.5, that's 7.5. Yeah, that's 7.5, that's 7.5. Now, the other thing that I want us to observe very keenly is that according to the laws or the properties that govern angles in circles, we know that angles subtended by the same chord are usually equal. Therefore, the angle at P has been suspended or subtended. It has been subtended, by the chord QR. And the same chord QR is the one subtending the angle at S, the small angle here. So it means this is also that 7.5. Yeah, that's 7.5, that's 7.5. Simply because they have been subtended by the same chord. Now that they have been subtended by the same chord, we are also supposed to conclude some other angles, and of course using some other property. PQRS, because the vertices are touching the circle, or rather the circumference of the circle, we can again say that this is a cyclic quadrilateral. And if it's a cyclic quadrilateral, it means the whole angle at S together with the angle at Q are what we call opposite angles in a cyclic quadrilateral. And they are supposed to add up to, what we call 180. So 180 minus 105, we get 75. So the whole of this angle should be 75. The whole of the angle at S should be 75 because it is opposite to the angle at Q. So if it's supposed to be 75, then it means the smaller angle at this point is also 37.5 because the whole of this should give us 75. Yeah. So that's also that 7.5. Yeah, that is something that you are supposed to understand. Very clear up to that point. There are very many angles that we supposed to conclude in several ways, but let's check what the examiner wants. PSR. PSR. Now, PSR is equivalent to 75. Reason because opposite angle to 105 in a cyclic quadrilateral. In a cyclic quadrilateral, and we know that in a cyclic quadrilateral, the two angles are supposed to add up to 100, and opposite angles must add up to 180. The other angle is a PQS. The angle PQS. PQS is the small angle at this point. Now, apart from the whole angle of 105 now, the smaller one, PQS, just that alone. Let me show you how we shall arrive at that particular angle. Let's apply as many rules as we can. Look at this. Just look at this. The angle at R is 37.5. We said initially that PS and QR are parallel to one another. If they are two parallel lines, then it means PR can be treated as what we call transverse, and the angle at this point will also be equal to 37.5. If that is 37.5, because the angle is now alternate. Yeah, that's an alternate angle. Alternate angle. Because it's alternate with the angle at R, then it should be equal. Alternate angles are usually equal. Now, that angle is that 7.5, meaning that the whole angle at P is 75. The whole angle at P is 75. Let me show you something here. So the whole of this is 75, and the whole of this is 37.5. So now we can talk about the smaller angle at this point, because that is a whole triangle. It's a triangle on its own. PQS is a triangle. So we take 180 minus 75. Then we also minus that 7.5. This is 67.5. 67.5. 180 minus 75 together with that 7.5. I'm getting 67.5. If a reason is needed, then we'll say angles in a triangle. Angles in a triangle are supposed to add up to 180. Thank you for being around, guys. Remember to subscribe. When we talk about is it a must uandike reason? No, it's not a must. More so in this case, it is not a must, but it's good for you to know the reason, because if the question appears in section 2 and even sometimes in section 1, sometimes you'll be demanded to give us the reason. So it's good for you to be knowing the reason. It is very good for you to be knowing the reason. Please make sure you turn up with a friend in our next lesson. Just turn up with a friend kindly. The concept on angles subtended by the same chord. Every angle formed is usually subtended by a particular chord. For example, the angle at P, that is QPR, is subtended by the chord QR. So QR is the one producing an angle at P, and the QR is also producing an angle at S. So those two angles are supposed to be equal. Thank you, Bonigas. Rapogi. That is Gilbert. Thank you. The subject of a formula. Look at number 6. Make T the subject of, then a formula is given. S equals to the square root of 3D into T minus D divided by 8. So we are supposed to make T the subject. In such a case, when there is a root which has been obtained, we raise the two sides of the equation to the power equivalent to the root which has been obtained. For instance, in this case, when we have obtained square root, we are supposed to square both sides. So S power 2, when we square the right-hand side, now the root symbol disappears. Divide this by S. Divide by 8, that is. At that point, we can multiply by, remember what we are making the subject is T. So we can multiply both sides by 8 over 3D. 8 over 3D for it to clear from the left-hand side. So 8 S squared out of 3D equals to T minus D. Look at that step. I've multiplied by 8 out of 3D. Both sides. 8 out of 3D. Okay, we could have multiplied through by 8, first of all. Then we go another step of dividing by 3D, which is more or less the same. So at this step, this is what I'm saying. We could have said by 8 throughout, so that we have 8 S squared equals to 3D T minus D. But now from my side, then we divide by, to remain with the T minus D, we divide by 3D. You see? So I did the step once. Okay. From Meru School, thank you so much. I can notice Meru School around. So now that we've already managed to remain with T minus D on the right, we can remain now with T by bringing negative D to the left hand side where it shall be added. So now this shall be 8 S squared out of 3D plus D. So now we are through with making T the subject of the formula. Thank you, thank you, thank you. Guys, remember to subscribe. Remember to subscribe and be reminded of our program here, please. Be reminded of our holiday program. This is now a very interactive section. Very interactive, whereby you can ask questions. You can learn from fellow students. Please ensure to register with us. Get the best from the best. We are having other tutors from other schools in the country, people with trusted performance. So please reach out and get the best from what we are going to offer this August holiday. Number 7. This is a question on SURDS. This is a question on SURDS. Let's look at it. Simplify 3 out of 3 minus the root of 7. To simplify means to simply rationalize the denominator. So we simplify by rationalizing 3 out of 3 minus the root of 7. So this is supposed to be multiplied by 3 plus the root of 7. And here, 3 plus the root of 7. So we multiply both the numerator and the numerator, by the conjugate of the denominator. On the denominator, we can open and have 9 plus 3 to the root of 7. Then everything is being divided by, everything here is being divided by. Now we are supposed to rationalize the denominator. Therefore, we square 3 and we also square root 7. 3 squared is 9 minus root 7 squared is 7. So now we are having 9 plus 3, the root of 7, divided by 2. So that is now fully rationalized. To rationalize, or simply to simplify a surd, means at the end of the day, don't have a surd on the denominator. Ensure that by the time you're finishing up with the working, at the denominator there is a rational number. That is it. At the denominator there is a rational number. Are you subscribing? Are you sharing to invite a friend? Are you benefiting as a person? Let's see. Number 8. Using a ruler and a pair of compasses only, construct. Using a ruler and a pair of compasses only, construct. What are we constructing? Part A, a triangle LMN in which LM equals to 5 centimeters, LN 5.6 centimeters, and the angle MLN equals to 45 degrees. So let's look at this on construction. The first thing, we come up with the line LM. The line LM. Make an arc L. Then now I stand on my ruler using a compass and I mark off 5 centimeters for me to identify with M. Yeah, 5 centimeters. So I mark 5 centimeters at that point. 5 centimeters that way. Then after that, something else that we're supposed to measure. Before measuring from L to N, we're supposed to know that the angle MLN is 45. And we are having very strict instructions of ensuring we use our compasses and a ruler only. No use of protractor in measuring of angles. We ensure that we construct all the angles. So to ensure that, we're supposed to stand at L, ladies and gentlemen, to measure 45, or to construct 45. So standing at L, we make an arc, and we also make an arc on the other side. Then standing on those arcs, we can make an arc above that, and another arc to cut the first one. So now, when I draw this, I'll have dropped a perpendicular at L. This is now 90 degrees. So with this, I'm supposed to bisect the 90 degrees for me to realize my 45. For me to get the 45 that I need. For me to get the 45 that I need, I'm supposed to bisect the 90 degrees constructed. So I stand at L again, I make an arc, and I make an arc here. Then standing on those arcs now, I'm supposed to make other arcs now at that point. This way, I will have bisected the 90 degrees angle, and I will have gotten 45. So this automatically now 45 degrees without measuring by a protractor, just construction. With that now, we can talk about from L to N, we need 5.6. So again, I measure 5.6 along that line now. Yeah, 5.6. Measure 5.6. So this is a length of 5.6 centimeters, which means this now point N. Then now we finish up with the construction whereby we connect L to N, already connected. Then we check N to L. N to L that way. After that, we're already having our triangle. The circle that cuts all the sides. Look at that. We need a circle that touches all the sides. So for you to come up with a circle touching sides, we are supposed to bisect angles. Remember, you can also be told at some other point by the examiner to ensure that your circle touches the vertices. But in this case, what are we ensuring? That the circle touches the sides. So for a circle to touch the sides, ladies and gentlemen, we are supposed to ensure that we bisect angles. So bisect any two angles. Standing at M, we can draw a bisector of the angle at M that way. So I produce a line bisecting the angle at M. Then after that, we also do the same for the angle at L. So we make arcs, we make other arcs inside there, and we come up with a bisector. That way. So you see, we are getting the in center. The in center is here. Where the two bisectors of angles are meeting, that is our center O. If that is our center O, then we'll stand there and draw a circle that shall touch. We draw a circle that shall be touching all the sides. So ensure that you do some perfect work from your side. Ensure that you do some perfect work on that side. So now I'm having a circle that touches the sides. Remember to be around till we complete the session. It's going to be interesting. People shall learn a lot from this, I tell you. People are going to learn a lot from shifting grids. I can check a few comments here. Thank you, Dennis. Thank you, my friend Dennis. Ramadan from UG High. Komarok, thank you. Kisumu Boys, thank you. St. Joseph's, thank you. Nyeri High, thank you. Kabianga School, thank you so much. Kipkoech, I notice you from Kabiaga. Thank you. Sironga Girls, thank you. Komarok, thank you. Gumo Boys, thank you. Mary Hills, Jiri School, thank you. So let's all continue to follow. The next question now. The figure below shows a triangle ABC. We can all see the triangle. Look at part A. On the triangle, locate the locus of points equidistant from AC and AB. Equidistant from AC and AB. That's a clear instruction. AC and AB. Then 5 centimeters from B. 5 centimeters from B. So we are supposed to know how to define loci first. Which loci are we talking about? A loci of points which are equidistant from two given lines. That means it is the angle bisector of the lines, the angle bisector of the angle where the two lines meet. AC and AB meet at A. So when we bisect the angle at A, we shall get the locus, or that line will be the locus of points which are equidistant from both lines. So I'm supposed to bisect the angle at A. So I stand at A, I make an arc, and I make an arc. Then standing on those arcs, I make arcs to cut each other somewhere there. Then I produce now the bisector. This way. So that is a locus of points which are equidistant from both AC and AB. From both AB and AC. Then now the other locus is a locus of points according to now the same part A, 5 centimeters from B. We know that there is a locus of points which are at a fixed distance from a fixed point. And in this case, we need 5 centimeters from B. So mine is to stand at B, using B as the center. Then I draw a circle, 5 centimeters radius. So standing at B, 5 centimeters radius, I draw a circle. So center B, then I draw a circle. Center B, I draw a circle like that. Once you've drawn the circle, those are the points, or that is the locus of points which are equidistant, or which are 5 centimeters from point B. So 5 centimeters from B means center B, we draw a circle, 5 centimeters radius. Now with that, we can get now to the part B, inequalities part. Shed region R inside the circle, which is less than 5 centimeters from B and nearer to AC than AB. When we say less than 5 centimeters from B, it means from the circle, the inner side, because beyond the circle, it's more than 5 centimeters. So when we say less than 5 centimeters from B, less than 5 centimeters from B, it means within the circle. Within the circle, and we've said inside the triangle. Then there is another point which is nearer to AC than AB. When we say nearer to AC than AB, remember the bisector is, this bisector is equidistance from AC and AB. But now we are talking of nearer to AC. Therefore, it means the upper side. So upper side and within the circle, it is the only region which has been shielded by the two. Look at the point which I've shaded. This is our region R. That's our region R now. The points which are less than 5 centimeters from B, and also the locus of points nearer to AC than AB, which means the upper side. So that is the region. That is the small region which the examiner wanted to see people shading. A very good question on locus. Very good indeed. I'm going to attach the WhatsApp link here so that you may join. Thank you so much for that idea. Thank you for that idea. We continue learning. Number 10, a very interesting question on longitudes and latitudes. Longitudes and latitudes. An aircraft took off from a point P, 65 in the south, 76 in the west, and flew due north to a point Q. The distance between P and Q is 5400 nautical miles. Determine the position of Q. Very good question. Determine the position of Q. Determine the position of Q. So let's see. Determine the position of Q. We're going to apply the formula that governs distance when it comes to this topic. 0 degrees equator, 0 degrees prime meridian. Now we are talking about in the south, 65 degrees in the south, then 76 in the west. 76 in the west that way. So this is the point. This is the point that we are calling P. Now, an aircraft is going to take off from point P. Then it shall move northwards, 5400 nautical miles. Now, when you move from P upwards, it means you are moving along what we call a great circle, a longitude, a circle of longitude, which is a great circle. So generally the distance along a great circle in nautical miles is usually given by 60 multiplied by theta. In this case, theta is the latitude difference. The latitude difference. You're moving along the same longitude, so no longitude difference. You're moving from one latitude to another. Therefore, the distance is known, 5400 nautical miles equals to 60 multiplied by the angle theta. So how do we get the latitude difference from P to Q? We take 5400 and we divide by 60. Ladies and gentlemen, I'm getting exactly 90. So there is an angle difference of 90 from P to where Q is. Remember, we are moving from 65 in the south, and we are supposed to cover an angle difference of 90. So for us to cover an angle difference of 90 upwards, to cover an angle difference of 90 upwards, then it means we shall cover first the 65 in the south, and we still move to the north part. So we shall finish all the angles, or we shall move through the 65 in the south, and we also penetrate the northern hemisphere, such that we can say that for us to get latitude difference, we need the first latitude plus the second one. So 90 equals to 65 plus the second latitude that we don't know. So how do we get this latitude that we don't know? We need 90 minus 65, giving us 25 only. 25 degrees, but where? In the north. 25 degrees in the north. So the position of Q shall be 25 degrees in the north, 76 degrees in the west. Yeah. 25 in the north. That is why the angle difference is what? 90. 25 in the north. So when you move from 65 in the south all the way to 25 in the north, you will have gone through an angle difference of 90. So that's what you're supposed to understand. That is what you're supposed to understand. Somebody was requesting for WhatsApp link, and I'm going to attach it in our chats. You can join our WhatsApp group using the link shared there. Thank you so much. Nyabururu girls, thank you. Thank you, thank you. Okay. Number 11, another interesting question. The equation of a circle is x squared plus y squared minus 4x plus 6y plus 4 equals to 0. On the grid provided, draw the circle. So for us to draw the circle, look at the 4 marks here. They are supposed to be distributed so well, the 4 marks. So you're supposed to work. The first thing that you're supposed to do is to ensure that we come up with a, because the equation is there, we come up with the center and radius for this circle. With center and radius, you shall be good to go. So we need to expand this now, whereby we first group the x components together, x squared minus 4x. So we're supposed to add a constant here. Then the y part, we also talk about the y components, whereby we are having y squared plus 6y plus another constant. Then now, the only constant that was initially there was 4. So to the left, 4 becomes negative, and we add the 2 constants also. How do we get the constants? Our intention here is to make perfect squares from the x component and also from the y component, so that you may know how to get the center and radius. So now the first constant should be given such that when we take the value of b over 2 and we square, we get the constant. So negative 4 over 2 squared. This gives us 4. Now C2 will be given by the value of b in the y components is a 6 over 2 squared. This is also going to be 9. So now the first constant is 4, the second one is 9. So with that now, we can write our equation now. X squared minus 4x plus 4 plus y squared plus 6y plus 9 equals to negative 4. We are adding 4 and 9 that way. So you see, I'm going now to factorize. The first perfect square should be factorized as x minus 2 squared plus y plus 3 squared equals to 9. Equals to 9. So we are having now an equation here for the circle, meaning that the center can be concluded very quickly as positive 2 and negative 3, and the radius has 3 units. Wow. Now that we have radius and we are having the center, then this circle can be drawn. This circle can be drawn in this way. We just need to draw the Cartesian plane. We draw the Cartesian plane. We draw the Cartesian plane. This is the y-axis. X-axis. The origin 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then we talk about negatives, negative 1, negative 2, negative 3, negative 4. Then we have negative 1 on the y, negative 2, negative 3, negative 4, negative 5. The center of this particular circle is going to be 2, negative 3. 2, negative 3 is here. So that is where you are supposed to stand now with your compass. Then you stretch it 3 units such that it shall pass through here. 3 units, it shall pass through here. 3 units on the other side, it shall pass through here. On the lower side, it shall pass through here. Then now you'll be able to do your circle very comfortably. As long as you've known the center and the radius to use, then you'll be able to connect very easily. Yeah, I'm not having some equipment here for use on the, but at least the sketch now will guide you. Yeah, that is the sketch. Look at number 12, ladies and gentlemen. Trigonometry 3. Determine the amplitude, period, and phase angle of the curve y equals to 5 over 2, the sine of 4 theta plus 60 degrees. We are supposed to know generally when we are given y equals to a, the sine of a k multiplied by x, then plus or minus a certain angle at this point. When given that way, and it can even be a sine function, a cosine function, kx plus or minus angle like that. Then we're supposed to know that A is usually the amplitude. Then when we take 360, then we divide by a K, we're supposed to get what we call the period of the trigonometric wave. And finally, when we take the absolute value of theta, we get what we call the phase angle. Yeah, we get a phase angle. So from this, now we can say, according to what we are having there, amplitude shall be 5/2, which is 2.5. The period shall be 360 out of 4, which is 90. Then the phase angle is exactly 60 degrees. So you just lift the values from the function if you've known how to analyze it. I don't expect now a student following shifting grades to miss such things. Yeah, you can share in the comment section, no problem. Look at number 13 now, statistics 2. Statistics 2. We are told that a basketball team scored the following points in 6 matches: 10, 12, 14, 16, 28, and 30. Using an assumed mean of 15, determine the standard deviation correct to 2 decimal places. So the first thing that we're supposed to do is to find how each value varies from the assumed mean. So let's get all the deviations first. Deviations, so that we get deviations squared. After deviations, we get to deviations squared. How do we get deviation? Each value minus the assumed mean. So each score minus assumed mean. The first score is 10 minus 15. Hey, I'm using a calculator. Minus 5. When we square, 25. 12 minus 15, negative 3. When we square, 9. 14 minus 15, that will give us a negative 1. When we square, positive 1. Then we can also talk about 16 to give us 1. When squared, we get 1. 28 minus 15 to give us 13. Now, when this is squared, we're getting 169. Then finally, there is 30 minus 15, which is just 15. And when we square 15, I'm getting 225. Yeah, so we have all the deviations, then squared. We are supposed to know that we can get variance first. Variance, which is given as s squared, is going to be the summation of all deviations squared out of the number of items which are here. So we need to take 25 plus 9 plus 1 plus 1 again plus 169 plus 225. Then we divide everything by 6. Yeah, 6 matches. So what are we getting here? 25 plus 9, that's 10, 11, plus 169 plus 225. I'm getting 430 out of 6. When this is divided by 6, we are getting 71.67. Remember, we are supposed to get now standard deviation, which is the value of s. Standard deviation is the square root of variance. So the square root of 71.66 or 667, the square root now shall be 8.47. Yeah, remember, 8.47. 8.47 to 2 decimal places according to the instructions provided. 2 decimal places. Very serious. You must ensure. Each value, according to how they have been stated here, 10, 12, 14, like that, we subtract each from the assumed mean. That's how we got the deviations. Number 14. Let's check number 14. A committee of 3 people was chosen at random from a group of 5 men and 6 women. Find the probability that the committee consisted of more men than women. We're supposed to give the probability space first, and I'm going to do this using a tree diagram. So let's see, when we take the first selection, we can get a man or a woman. Getting a man should be 5 out of 11. Getting a woman should be 6 over 11. That is the first selection. Now, second selection, if we had chosen a man, we can still choose a man or a woman. So choosing a man for the second time, now the probability becomes 4 over 10. But woman, it remains 6 out of 10. What about the second selection? When in the first one, we had selected a woman. Getting a woman for the second time now goes to 5 over 10. And for men, remains 5 over 10. That way, we are coming up with a probability tree diagram. Look at this. The third and the last selection, if we had picked a man here, we can still pick a man again or a woman. So picking a man for the third time now goes down to 3 over 9, which means for a woman, that is, should be 6 out of 9. If we had picked a woman, we can pick a man or a woman once again. When we had picked a woman, picking a woman again should go down to 5 over 11, which means for men should be 4 over 9. Yeah, that way. I'm just placing the respective values of probability so carefully, and I hope you are also very careful on the same. Remember, after the presentation, this lesson will still be found through the same link and in the same channel, Shifting Grades Online School. So please be found with us. Make sure you can still follow up. Man, woman. If we had picked a man at a probability of 5 over 9, then picking a man again means that the probability will go down first to 4 out of 9, and woman should be 5 over 9. That way. Then if we had picked a woman here, there is a probability of picking a man or a woman once again. Picking a woman was 5 over 10, so it should go down to 4 over 9, which means for men, 5 over 9. That's it. So with this now, allow me now outline the probabilities at the end of this bracket now. At the end of everything, we can outline the probabilities. In the first case, we are having man, man, man. Then at this point, we have man, man, a woman. Then we have at this point, man, woman, man. At this point where we are ending with a W, we have a man, woman, woman. At this point, we have woman, man, man. At this point, woman, man, woman. At this point, woman, woman, man. And finally, we have woman, woman, woman. With that analysis, now we can get back to the instruction. Find the probability that the committee consisted of more men than women. So where do we have more men than women in this case? More men than women. no woman here. So we talk about more men than women. That is the first case. More men than women. Another case. More men than women. This is another case. And now I'm not seeing another case where the men are the one who are more. So in the first case, we need probability man, man, woman. Probability man, woman, or probability man, woman, man, or probability woman, man, man. Those are the cases where men are 2, but only 1 woman. So in the first case, man 5/11, man 4/10, and woman 6/9, or means addition in probability. We start with man once again, 5/11, woman 6/10, and man 4/9. Then we start with woman 6/11, man 5/10, and then man again 4/9, that way. So let's check these probabilities now. So I'm going to use my calculator so that I may go very quickly. 5/11, 4/10, 6/9, plus 5/11, 6/10, 4/9, or 6/11, 5/10, and 4/9. I hope you're also computing, and you shall confirm with me that the final answer is 4/11. When we talk about more than, we mean at least the 2 genders are represented, but with more men. So in the first case, whereby it's 3 men, you cannot say that men are more than women, yet there are no women at all. Man, man, man. That is not included, please. So let's read the question carefully for us to get the right answers. 4/11 now becomes our final answer. I can see the coverage is so clear. I'm also watching myself from a different screen, and I can see that everything is so clear. Number 15, ladies and gentlemen, as we wind up. The area of a triangle is 24 square units. The triangle is mapped onto image P by the matrix 6, 5, 3, 4. Find the area of the image P. What we're supposed to know that area scale factor is usually given by the absolute value of the determinant of the matrix involved. So how do we get determinant? Product of the elements in the leading diagonal. So product of 6/4 minus product of the elements in the other diagonal. So 3 and 5. So I'm talking about 24 minus 15, giving us 9. So the area scale factor is 9. If the area scale factor is 9, it means area of P out of area of the triangle, which is 24, should give us 9. So how do we get P? We need to multiply 24 by 9. So the image was having area, which is equivalent to 24 by 9. This is 216 square units. Yeah, square units, that way. A very good question. And finally, we go to number 16 here. Given that the matrix OA equals to 3i plus 4j plus 7k, and OB equals to 4i plus 3j plus 9k. Is that a plus or minus? The scanning there was not very careful, but I will assume it's a plus. And also a plus at this point. Yeah. Then OC equals to I plus 6J plus 3K. We shall confirm whether it's a plus or a minus. We shall confirm. So, how do we show collinearity? We first calculate two vectors according to the provided coordinates. Let's get a vector, for example, a vector AB. Then we also get another vector AB. Vector AB and AC. Let's get these two vectors. How do we get vector AB? We need B minus A. So we can work out B minus A, whereby we need 4, 3, 9 minus, that is B. So A is 3, 4, 7. I'm getting a negative 1. No, positive 1. 4 minus 3, 1, negative 1, and 2. What about vector AC? We need C minus A. So C is 1, 6, 3. Then we subtract A, which is 3, 4, 7. This is going to be negative 2. This is going to be positive 2. And this is going to be negative 4. That way. So now we check whether these vectors are related in any way. Is one of the vectors a scalar multiple of the other? For example, when we say that AB should be multiplied by a certain scalar multiple to give us AC. Is that true? K multiplied by the first vector equals to the second vector. Is it true? Let's use the x components, for example. From the x components, K equals to negative 2. What about in the y component? We have to take K minus K multiplied by negative 1 equals to 2. So that's negative K equals to 2, meaning that K again is negative 2. Then finally, according to the Z components, then 2 by K equals to negative 4, meaning again that K is negative 2. So the sign that we've guessed up there was right. It means that negative 2 vector AB, negative 2, when it multiplies vector AB, we usually get vector AC. We get vector AC. And to show that one vector is a scalar multiple of the other, it means they are parallel. So in this case, vector AC is parallel to vector AB. And in the measuring of the two vectors, there is a point that appears twice, and that is point A. So we say A is a common point. A is a common point. Hence, A, B, and C are collinear. They are collinear points. So to show that two points are collinear, we just check that two vectors expressed from the points are scalar multiples of one another, and that they have a common point. Before we conclude this section 1, allow me to remind you our program whereby you can purchase airtime from wherever you are for any network by just going to your M-Pesa, Lipa na M-Pesa, 737356. Then the account number is the phone number that you're purchasing the airtime for. After that, now you enter the amount, you complete the transaction, and you receive the airtime instantly. So please utilize our facility and invite your friends to the same. Remember our holiday program here, whereby we are having very interactive sections whereby you can ask questions, interact with the teachers through Google Meet. please reach out through the number attached 0704 15 3366 and get assisted. We shall help you to achieve your best. We shall help you achieve your goals. So thank you so much. See you next time. Bye bye.